Hey guys, welcome back to AlgoYogi. We are doing graph series and our next problem in the list is shortest bridge. Let's go to LeetCode, give this problem a read. So you are given an n cross n binary matrix called grid where 1 represents land and 0 represents water. An island is a 4-directionally connected group of ones not connected to any other ones. So there are exactly 2 islands in this group. You may change zeros to ones to connect the 2 islands to form 1 island. Return the smallest number of zeros you must flip to connect these 2 islands. So basically, we have done like a lot of problems like that, and this problem doesn't have any pictures to understand, so I have to copy it from one of the previous problems, and this exactly represents a problem statement. So we are given this grid. Okay, right now it might not be n cross n, so let's just count. So 0 1 2 3 4 5 6 0 1 2 3 4 5 6. Wow, I didn't plan it that way. Okay, awesome. So now we are given exactly 2 islands. These are the islands. This is island 1 and this is island 2. All right, now these 2 islands, we need to flip a minimum number of, or a smallest number of these water bodies, these zeros, into ones, and so that we can connect these islands. So as you can see right here, you can flip this 0 to 1 and then we will be able to connect both islands together, right? So we just need one flip. All right, we just need one flip. But that's not the only way of connecting these 2 islands. There are other ways, but that's the best way. I'm saying that's the best way. You could choose to flip these two, or maybe these 2, or maybe these 3 to connect. Well, that basically explains what the problem is asking us. Now let's see how are we going to solve this. So first thing is locating the island, just one island, and from there we're going to start our BFS to reach the other island, and whichever path from my BFS returns reaches the other island earliest, from there we just return how many level we have already traversed. It's crazy how simple this problem becomes if you think about just locating one island. So we'll use two for loop, nested for loop to locate just one, so that we have an idea of where our first island is. Now let's say you come across that island. So what you will do is you'll add all these grid indexes to your visited set. All right, so we'll add them to our visited set. Once you add all of these to your visited set, then what you'll do is you will run BFS on all the indexes, or like these pair of values which will represent row and column for all these values, this first island. And from here we will be running BFS just so that we can reach the other island, and whichever, because at one level we will be traversing, let's say we start with this grid, this cell. So on level 1, this grid will be traversing right here, then right here, and then right here. Okay, we are not going to explore the visited cells again, but we will definitely append on level 1 all of these. But at the same time, we will be doing it for all the other cells. Okay, because it's a BFS, and BFS. Let me just show you. Like, let's say if this is your graph, and it will be easy to understand, by the way. So if this is your graph and I'm starting my BFS right here, on first level I will be able to traverse all of these nodes, okay, in my first basically on first level. So because it's BFS is also a level order traversal, so that means at the same time I am basically trying to access all of these since they are currently in my queue. So I will be appending all of them in my queue, and in my grid right here I have appended all of these cells into my queue so that I can run my BFS right from that initial state. So all these cells that are basically are pointed by this red arrow, those are the cells we will be visiting on our level 1, and once we are there, basically we'll keep a check that these are zeros, we're looking for zeros, and once you visit those, so these all cells are on level 1, and then from there you will be visiting your next or next neighbors, set of neighbors. So these are those neighbors. So for this is the neighbor, this is the neighbor. I'm not going back, although you can, but I'll keep a check that I am not trying to visit the grid, that visit the cell that I've already marked visited. So if you see right here, and this level, I have reached another island. So whenever I'm seeing during that BFS, I see I come across a 1, that's when I will return my answer. That means what is the level from where I have made a call to this 1. So this is the level 1. In this example, that was the level 1. Okay, so I should have carried my BFS. So from here I will choose another node to basically run the BFS. So these are the next level. So this is level 1, and this was level 2, and this is the last node on level 3. Okay, this is what I'm saying. So we will know our answer while running our BFS on basically all the cells of island 1, and once you encounter the island 2, that's when you return that particular level, or we can call it answer. So once again, let's go over this so that we have a very clear idea what we are actually doing. So first thing first, we'll explore our grid, and then we'll find the one of the islands, whichever we come across first. From there we will append all of these to queue, all of these cells addresses, and then from there we will run BFS. So run BFS, and after running BFS on this queue, you will come across find island second. Okay, and then you find island second and return level at which you found, because it's guaranteed that we will be given 2 islands in this water, and then we're gonna come find out the first island and then try to find the second one from running the BFS. So we'll be implementing we can say we can do a DFS to find all the cells of this one and then a BFS, but we can do both BFS as well. They'll be equally efficient in this case. So I think now it's all all about transitioning our thoughts to code, and let's do that. And I would really highly recommend you guys to just write your own code. Watch the conceptual part. I'm not here to ask you to just watch the video till end, because it's not important to me, and it shouldn't be important to you, because what's more important is just understand the concept, and then right from there, once you have that all figured out in your head, just translate that code, just translate those ideas into code. So here, first thing, let's just get all the dimensions. So it will be row and column, both are going to be same in this case, although since we have been doing it different, for not all the time these are given as matrices, they are given as grid, and in grid this is how you calculate the row and column. And then for visited, we can create a set. So now what we want to do is run basically have to nested loop exploring all the cells of our grid for R in range R. Okay, for C in range, say C in range column. Okay, now what I want to do here is if this grid at R and C is basically pointing to 1, that means it's I just found one of the edges of my island, so now I gotta explore entire island and add it to my visit set. So here what I'll do is I'll just run BFS I'm calling it DFS, but BFS on basically this R and C. Okay. Now there is one more thing. Let me come back to it later. So let's just define our BFS, which takes R and C. We'll create it. Now let's append it to Q, because in BFS I'll be adding it to my Q. I don't want too much gap right here. So I've added it to my Q. Now I will be running a while loop on my Q. But before that, I think I should add it to my visited set, because I'm currently visiting it. So R comma C. Alright, now I will have this while loop while Q is not empty. So let me load all the values of Q. You can keep running the Q, explore all the values in Q, but I just like it this way. And I will have Q emptied. Now for node in my small Q, this particular node will have R and C. So I'm emptying those. So for dr comma dc in basically all the directions. I'm sure you have already done this. So increasing the row, decreasing the row, increasing the column 0, 1, and decreasing the column, so 0, -1. So in all the direction, because we are only allowed to explore them 4 directionally. All these land is connected 4 directionally. So now at this point, if let's create the new row and new column. So new R and a new column, new R and new column. So this will be dr plus R, dc plus C. All right. Now this is what I have here. Okay, so if this new R is greater than equals to 0, and this new C is greater than equals to 0, and new R is less than R, and new C is this is the typo that I don't want to make. So new C is less than C, and grid at that particular also, this new R and new C is not in visited. Okay, new R and new C not in visited, not in visited, and yeah, I don't want to hide it too much. And at this new R and new C, the value is equals to 1. Okay, so if that's the case, that means that is a piece of land, and I want to add it to my Q. So Q dot append new R comma new C. All right, and at this position, I also want this to add it to my visited set. Okay. So I'm adding same thing. Okay. So now what must I have done is, till this point, what I have done is I came across one of the island, and then I have added all that to my visited set, all those cell addresses of this island. But I just want to explore one island. I don't want to explore, I want to quit before I start exploring the other one. So I'll have this I'll call it flag found initially false. False starts with a capital F in Python. So this false, and if found like island 1, then I will break. But then here, if this is the case, then I want to mark found equals to true, and I want to break from here. All right, so this will just help us find only one of the islands, and then we are out of this. So here I will create the queue for my second round of BFS, and we don't have to create, we can't utilize this one. This was just to explore. This could be DFS. You could have used DFS also if you find DFS to be DFS as easy algorithm to write. So now here in the queue, what I'm going to do is I'll convert that visited set to my list, because it converts all the cell addresses of the first island. Now I have this queue, I have this list, and then I'm going to create this level or answer, whatever. Let's call it level. So level initially will be 0, and then I'm going to start my BFS, or this entire thing is BFS, but like this is the actual while loop we want to start to explore. So I'm loading all the queue. So queue, let's explore all the nodes. And honestly, I could have just copied this thing, and let me just copy this right here. Okay, let me just copy it right here. So this time as well, what we are actually doing is we're going over all the nodes, all the neighboring nodes, right? All the neighboring nodes, and I'm going to do just little trick right here. So right here in this one, what I'm trying to do is I will have those addresses of my current node, and then I'm going to start exploring all the directions, find the new cells addresses, and if it is in my range, and also it's not in visited already, so what I'll do is I'll have it go like this. So if that is the case, and if this is a 0, that means I have to start exploring at that 0. So what I'll do is I will append, so I'll just say if grid at this new R and this new C is equals to 0, that means I want to append it to my queue and then also add it to my visit set. But what if it's equals to 1? That means I have found the other island, and finding other island means I just return the level. Level means how many values I had to flip before I could just find this second island. But if you see right here, level is 0, and on the very first neighbor I found a 1. That means the level will be 0. I wouldn't have to flip anything, so I'm finding it on level 0. I didn't have to flip any of the water bodies to convert into land to connect the island. But let's say I'm out of this for loop. That means on one level I have explored everything, which means I will increment the level by 1, because I will be exploring the another set of values in this queue, which I will be exploring after putting them all into the small queue and then running a for loop on that small queue. So I think that would be most of the time, like we should be able to exit from here, and I guess all the time we will be exiting it from here, but it doesn't hurt to just return level here as well. Okay, so I'm going to zoom out so that you can see the entire code. This is the entire code. By the way, I've already said that at this place, this BFS that we've used, you can use a DFS as well, right? Explore just one of the islands. We're using the flag to basically quit before we start to explore the other island, and then we have the same BFS. And if you remember, I've just copied this code. Most of this code, entire code right here, is just like I wanted to have this condition, so that I can return. But I'm sure you can find a way of finding overlapping these two functions, because they're doing the similar thing, not the same thing. So what I'll do now is run it. Let's run it. And yes, I'm so happy that on the very first go it just ran. Awesome, 89%. Okay, so this is entire code. I'll slowly scroll it, and then let's just write the time complexity. That will be n square, so n cross n or n square, whatever you guys want to call it. Writing this way is better. And same goes for space complexity, because we're adding everything to my visited set. Not everything, but most of the time, like we might end up, in worst case, we might end up visiting everything. Okay, so big off and square as well. So that is it. It was like, it's a lot of code, but the concept is so clear. Like, right, like sometimes you will see like some of the concept part of the solutions is just so tricky to understand, but the code is just really, really small. But this problem was one of those problems where like the description is just super simple, and we know what we are trying to do, but like the code had to be written like pretty lengthy, you know, to get our answer. Now let's go back to AlgoYogi, mark this solved, and see you guys later in the next problem. Until then, bye-bye.